Hey guys, it's Mrs. Opal here, and
Anders Opal. And Annika Opal.
And we're here to give you a review for the chi-square test. Just a friendly reminder, there's 3 different chi-square tests. There's the goodness of fit test, that GOF. There's homogeneity and independence. Okay. My daughter just told me I spit on her. Sorry, sweetie. Couple different things that you need to remember. So keywords are things that you need to know when it comes to goodness of fit, homogeneity, and independence. The first one is for goodness of fit, or for all of them really, you need to be asking yourself how many samples are there and how many variables. Hey, Anders, how many samples are there for a goodness of fit test?
1.
Good job. And Annika, how many variables are there going to be for the goodness of fit test?
1.
Just like if you remember in class, we did an example about hockey players and their birth year. So it was 80 hockey players, and that was the sample, and then 1 variable, their birth year. We also did a sample about the different types of nuts in a mixed nuts container, and the sample was the number of nuts. The variable was what type of nut they were, okay? Then we move on to homogeneity. So homogeneity is how many samples, Anders?
1.
Oop. Nope.
2.
2. You're right, Anders. It's okay to make mistakes. Mom's mistake. And then, Annika, how many variables are there?
1.
So, for example, you could look at the distributions of AP scores for different years. So you could look at my year of 2007 that I taught at 2008 and 2009. So that's 3 samples. And then the distribution would be the variable of AP scores. Finally, the chi-square test for independence. Hey, Anders, how many samples are there for 1? Or I told them it's a 1 sample for independence. But Anders, how many variables are you looking at?
2.
And this is a key word in independence is association, as well as homogeneity. You're going to see words like different and same, but really just paying attention to how many samples there are, how many variables there are. All right, guys, thanks for your help. I'm going to talk a little bit longer now, okay?
You're welcome.
Okay, say bye to the AP kids.
Bye.
Oh,
See you later.
you okay, Susie? Okay. All right, so here we go. Let's talk a little bit more. What's going on? For the null hypothesis, what I like about goodness of fit, homogeneity, and independence is you just always say, hey, is the claim, is the same, or is independent? And then that HA is not the claim, is not the same, is not independent. Now, I know some teachers, instead of saying is independent, they say is not associated. And then they'll talk about, or they'll use things with association. So they'll say there's no association. So no association means they're independent, and then they'll say then they're trying to prove that they are associated. You can do this, and I know some AP teachers that do that. I just don't like it personally, because why not just stick with the is not for all of them, okay? So if you like this and it works for you and you're getting the correct answers, that's fine with me. It's just not my preferred style, okay? So on this page, what did we look at? We looked at some keywords. How do we know the difference between goodness of fit, homogeneity, and independence? We talked about the null and the alternative and how it's always is not. Next, what I'd like to talk about is just some different things that you need to remember and have memorized. So we have that goodness of fit, okay? And the homogeneity versus independence. Now, homogeneity and independence, the test is run the same. You have the same, just exactly how you do it. The method is all the same. The only thing that's different is the context. When you're doing expected counts for goodness of fit, you do what you would expect if the null is true. So if you go back and you look at our notes from that Thursday before we were off because of this pandemic, you would see that, hey, to figure out for the expected counts for the number of hockey players and their birth year, we would expect them to be the same. So we took that 80 and we said, well, if it was all equal, right? If we're saying hockey players' birth months should be equal across quarters, then those 80 players, right? 80, the 80 players, it should be 20, 20, 20, and 20. Okay, we just took that 80 divided by 4. With the macadamia nuts and the mixed nuts example in our notes, and that's actually a part of your homework problem as well, so you can go refer to it there. With those mixed nuts, what we did is we said, how many nuts do we have total? And then the manufacturer said like 30% of them should be macadamia, 20% should be pistachio. So then what we did for that one is we just took N, which was our total number of nuts, times the percentage that they gave us to figure out the expected value there. With homogeneity and independence, it's much more rigorous process, or just takes longer. You need to take the row total times the column total and divide by the table total. Now, here's the deal. I showed you in my videos that you don't have to do this all by hand. The calculator will do it for you, but I guarantee, I'm 99% confident that this will be 1 or 2 multiple choice problems. And it's just a matter of memorizing. There's really not a whole lot of higher order thinking going on when you talk about just a row total times a column total divided by a table total. So why not get those couple points on that AP test by memorizing this? It doesn't take that long. Moving on. Let's talk about degrees of freedom, DF. For a goodness of fit, it's the number of categories you have minus 1. So for example, in that hockey player one, we took, there was 4 months or 4 years, 4 quarters. Can I talk? I can talk, sorry. There's 4 quarters of the year, the first, second, third, and fourth. So 4 quarters minus 1, so we had 3 degrees of freedom. Now in homogeneity and independence, you're gonna have a two-way table. So you take the number of rows that you have, minus 1, times the number of columns you have, minus 1, and you multiply them together to get that degrees of freedom. The last thing I want to talk about is just using that formula sheet. Okay, and I'll go to that now. Give me 1 second. Okay, so this is like the golden page in AP in my opinion, right? It's got almost everything that you need. So we go down and you can see that chi-square statistic. You must show your work on how you got that chi-square statistic, even though the calculator will do a lot of it for you. Just a friendly reminder, the sum of the observed minus the expected squared divided by the expected. Okay, next is how do I use this formula sheet? So friendly reminder, we talked about this in class. In case you forgot, the chi-square distribution is always skewed to the right, and your chi-squared value is always looking for the area to the right of that line there, of that value, okay? Now, let's just play pretend. Let's say we had 3 degrees of freedom, okay? So you can write that down if you need to remember. But if I have 3 degrees of freedom and my chi-square value was 8.2, okay? So I'm gonna go across the row and I'm gonna say, hey, look, 8.2 is in between 7.81 and 9.35, okay? So then what I do then is I scroll up and I know that my p-value is between 0.025 and 0.05. So you do need to know how to use this table as well. All right, I did make videos for all of these. I'm gonna make a video for chi-square goodness of fit, just summarizing the notes. We already did it in class, but I can just quickly talk through it. I miss y'all so much. I hope you're staying healthy, safe, and just keep smiling, you guys. We'll chat soon.